Alright, so this week we're looking at integration, and integration, some of you might know, is the opposite process to differentiation. So first thing we're looking at is indefinite integration. I'm going to put plus c here, which will become reveal what that means. This is the easier type of integration. So we can do a quick recap on our differentiation. Right, so there's our differentiation recap, or differential recap. So remember, with differentiation, you put it in the form x to the power something, then you times by the power, and then you subtract 1 from the power. Cool. Right, with integration then, so just box that off. Integration. We're going to do the opposite, so we're going to add 1 to the power. And then we're going to divide by the new power. So exact opposite process with y is x to the n. The integral, so we've got our own sign for integration. Integral of y, or integral of x to the n equals x to the n plus 1 divided by n plus 1. And then we add something on the end, we put plus c on the end. So the reason we do that, this is an integral sign, it means integrate this. Next we should have the letters dx there. Dx for this year, we can just pretend all dx does is it tells you which letter to integrate. So dx means integrate the x's in this, so we add 1 to the power, divide by the new power, and we put plus c on the end. I'll just show you why we need that plus c, but that is the basis of all of our integration for this year. So y plus c. Right, so let's imagine that we have y equals 5x plus 2. And we differentiated this, so if we differentiate this, you get 5. Now, let's imagine we then wanted to integrate this to get back to where we started. The integral of 5 gives us 5x. But we've lost that 2. When you differentiate the 2, it disappears, so we can't integrate nothing and randomly get 2. So whenever you integrate, put plus c, and that c is just in case you lost something like this during a differential. So we always add c. C stands for the constant of integration. And it just makes up for the fact that sometimes numbers disappear when you differentiate them. So plus c will always be in place of one of those numbers and lets you find it later on. Cool, right, we'll try some examples then. So we've been given a differential here, find y. So in order to get y, we're going to integrate the differential to get back y. So you can kind of think of integration as undoing differentiation. If you differentiate something and want to get back to where you started, you integrate. So we're going to integrate 6x plus 2 over x cubed minus 3 root x. dx. Again, that tells us which letter we are integrating. I'm going to write this out because at the moment we can't integrate these, we need to write them with our indices. So integral of 6x plus 2x, bring it up, so 2x to the power minus 3 minus 3 lots of x to the half dx. That's really important you put in the integral sign and you put in dx because up until you get rid of these you haven't done any integration. So these tell you that you're planning on integrating this bit, and the next step we're going to do the integral and get rid of those signs. So 6x, the x power goes up, so it was power 1, now it's going to be power 2 x squared, and we divide by the new power, so 6 divided by 2 gives us 3. Next one, power goes up, so minus 3 plus 1 is minus 2. Divide by the new power, so we get 2 divided by minus 2, leaving us with minus 1. Next one, minus 3x to the half, well the power's going to go up to give us 3 over 2. Divide by the new power. Now dividing by a fraction is the same as timesing by the reciprocal as we learned before. So instead of dividing by 3 over 2, we can times by 2 over 3. So 2/3 times minus 3 leaves me with minus 2 x over 2 plus c. So there is the answer to our integral. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So you can just flip that. Right, let's try another one of these. We'll go over it for this time. So we're told the differential of x, the gradient function, 7x squared minus 5x plus 3. Find f of x. So we want to find f of x, we're going to integrate that. So integral of secant x squared minus 5x plus 3 dx. So the power goes up, x cubed, divide by the power, 7 over 3. There we go. Power goes up, x squared, divide by it, minus 5 over 2. Power goes up, 3x to 1, divided by 1, and you're left with plus c. So nice and easy, you get the hang of these. If you can differentiate, you can definitely integrate. It's just the opposite process. Right, let's try a slightly hard one, and that's it for the first video on this topic. So integral of 6x plus 3 over root x. Now we can't just jump in and integrate it because we've got fractions and loads of stuff going on. What we're going to do first is simplify this. So we get integral of 6x plus 3 divided by x to the half. And now I can turn this into two fractions because we've got one thing on the bottom, two things on the top. So we can say it's the integral of 6x over x to the half plus 3 over x to the half. And go one step and simplify these. So we can say it's x to the power 1 divided by x to the power half. So subtract the indices to get 6 x to the half plus 3 x to the minus half dx. Now that it's like that, we can jump in and do the integration. So power goes up. So add 1 to a half, you get 1 and a half, which is 3 over 2. Now divide by the new power, so times by the reciprocal. So 2/3 of 6, which is going to be 4. Here power goes up, so minus half plus 1 is a half. Divide by the new power is the same as timesing by 2, so we get 6x plus c. Cool. Right, that's it. Next video, I think we're doing definite integration, which is slightly harder. If you want some practice on this, just differentiate something and then try and integrate it to show you get back to where you started. So anything you can differentiate, you should be able to integrate to check. If you want to check you did this right, differentiate this and you should end up back where you started. So
these will undo each other, so you can always use them to check your answers.
Cool.